Let's talk about the constructors in a class. So a constructor is a special method or a member function. Think of it as a function that initializes our overall object. The constructor looks like a function, but there's some oddities to it because it wants to identify it as a constructor. And here's the weird part. It's very similar to functions. We can also overload constructors. And I'll show you examples of that here in a second. So our first example of a constructor is just what we have here. Now notice the constructor matches the same name and same capitalization, lower, whatever you want to call it, same exact string here for name. That's how we know it's a constructor. But here's the other thing. Notice it looks like a function, because it really is. But it doesn't have a return type, not even a void in it. It basically is saying, hey, I'm a little bit special. I'm the one that's going to be setting things up for the student. I'm going to be eventually setting up the name and the ID for this particular student. That's how it's set up. And notice it's also in the public section as well. Now, to add the functionality to the constructor, we're going to use what's called initializer list. And that is, well, just setting the names to it. Now, I know you're looking at it like, wait a minute. Basically, that's name being set to name and then ID exactly the same thing. Now, that's the preferred way of doing it. And the neat part is because it is part of the constructor, remember us talking about the this portion before? Because it's the constructor, there's no confusion on which name is which using the identifier list in this. So it shortens our code a little bit, gets it over and done with, sets up our overall instance of this class, and that's the start of our constructor. Now, this was another way that we could have done it. Now, notice it says it's not preferred, but this would have been the same ideas that you and I just talked about when it came to the this item. This does work, but again, notice it says not preferred, only because it's more code, and well, how many of us are lazy? All of us. This does the exact same thing as the other one, but it's just using the initializer list. There's no issues or confusion on which one is which, and we wouldn't need to use this keyword if we use the initializer list. So when we're using the constructor, this is what it's going to look like. Everything's set up. We've already talked about the setup here, talked about the code and getting it all set up. But then, how do we use it? We have student Joe, Joe Smith, and 1, 2, 3, whatever. Here's the interesting part, though. Just like a normal function, we have to match the parameters with the name of the function. Now, you look at student and it says, well, Joe's not a function. I get you. But this is the first time we're creating the student Joe. Because it's the first time we're creating it, it's going to match it with the creation using a constructor. Now notice, then it's a one-to-one match. You have string name here, here's a string here, and then integer and integer here. So there is a matching of exactly which constructor we're calling it. And again, it's using a constructor because we're defining our first instance of Joe in this program so far. Now, if you oops one of these, let's say you made this a double for some reason, then yeah, it's not going to match the constructor. The exact same thing would have happened if you would have had a normal function. But there's going to be a little bit of tweak to this, so hang on. So here's our tweak, is that we can do the defining of the rest of our constructor outside of the class. That's not a big deal. Again, very similar to the function. Now also again, there is that scope operator saying that, hey, this constructor belongs to the student class. class. And again, the overall same thing with our initializer list. So that's one little tweak. Here's our next tweak. Remember overloading? Yep, you could do the same thing with constructors. Now look at the difference between these two constructors. Their name is exactly the same. But as you know in overloading in C++, the parameters have to be different. And here, it's the number of parameters that are different. This one has string name and integer. This one just uses string name. The name is set, and notice the ID is set by default by the programmer to 0. Not by the user, but by the programmer initially to 0. So how would that work out? Just to stir the pot even more, I'm going to add another one. This time, it's a student that doesn't accept any parameters. We'll give the name by default a blank and give their ID as a 0. So I'm giving you 3 different overloaded constructors. Now I'll show you how we call them. So that last one that I showed you, where frankly it's right here, where we have no parameters at all, that's called a default constructor. Meaning, if I call Amy, and notice I don't pass any parameters into Amy, by default it'll set her instance to null, empty set of quotes for the name, and ID was equal to 0. Now, how do I know it's going to call that particular one? Well, notice that we don't have any parameters. This function doesn't require any parameters. This Joe had 2 parameters, a string and an integer. That's exactly what this constructor needed. So for student Joe, it would use this constructor to go ahead and build the overall instance. So that's the really neat part about doing all of this, is that we're given a little bit of leeway on exactly how we want to construct things. Think about it this way. I'm a parent. I always knew my kids' names before they were born, but some parents don't. So there's going to be access. There's going to be one constructor where you're given the name, you know the name right off the bat, and there's another one where the child's still born, you just haven't given the name quite yet. So that's another real life scenario. The other interesting part about this is that we haven't discovered this yet, but you can create an array of your new object just like you would if you had an integer array, a float array. Yes, this array is going to be much more complicated because you have much more items and many more data members within it, but you can use it for the same idea. And that's the beautiful part about using OOP in programming. So last few notes on a default constructor. That's the one that had a completely empty set of parentheses here. Number 1, in C++, it actually builds it for you already. So let's pretend we didn't have one for Amy. It would automatically do it, and it would set her values to null, basically, until we filled in values later on. But the other important part is that if you define other constructors but not a default constructor, your compiler is going to have an issue. So it's not really hard to build your own default constructor, let's put it that way. But again, even though C++ does it at first, as soon as you start adding non-default constructors in it, it's going to have an issue. I was going to say something else, that you go ahead and need to create your own default. You need to do it anyway, because in your application, you're still, your theory of it and everything else like that, don't ever let object just sit out there with no values. Give it something so it can, well, frankly, be improved on and have other functions call it, your accessors, mutators, so you get some type of response and be ready for it.